All right, ladies and gentlemen, welcome to today's little extra review before your quiz that's happening this week. Hopefully, you've gotten the notes, the Conic section essentials notes. It looks like this, and it just has the essentials about circles, ellipses, and hyperbolas. And hopefully, you also have the assignment, which looks like this, and it has you writing equations for conic sections and getting different bits of information about conic sections. So you need both of those during this little video lesson here. I'm going to be using examples from your assignment and work through those for you. But before we do that, make sure you know what the equation of a circle is, make sure you know what the equations of ellipses are, and the Pythagorean relation for those. We're going to be using them. And make sure you also have it for the hyperbolas, and make sure you know how to get the asymptotes and the Pythagorean relations. We're going to go ahead and do that throughout this review and do some of these problems together. So, first example is going to be number 4. We have to write the equation for this hyperbola. You should notice that this is a right-left one, and that means in our equation it's going to be the x squared first, and then the y squared part's going to be second. It's going to be 1. We got to do some subtraction. We got to do our line underneath there. And you need to also find your center, so you know it goes up here. Center sitting here where those asymptotes meet at, which is at -2, 0, which means h is -2 and k is 0. So y squared is going to stay the same, but you're going to have x minus -2, which would be x plus 2 squared on top there. And now you have to find your a and b distance. Your a distance is how far it is from your center to a vertex on either side, which comes out to be 3. And so this number that goes underneath here is that number squared, because it's a squared. So we're looking at 3 squared down here, which is going to be 9. And then here you have to get your b squared, and your b is, you got to look at your asymptote slope here, and you can draw a little box and figure out the distance is from there to there. If you're wondering where the box kind of comes from, you go from your vertices, and you draw a vertical line, and where it hits on either side is going to be the other ends of the box there. And you can get this distance, which comes out to be 5. And so this number down here is going to be 5 squared, which is 25. So there you go, you got your equation. Let's go on to another one, number 6. You're supposed to get the center and the radius of this circle. It's going to require doing some completing the square. And so we're going to separate this out into the x and y parts. And while we're at it, we're going to move this 133 to the other side. So we're going to add 133. That's a bad 3. So it's going to equal 133 on the right. And I'm going to do the x part in blue and the y part in red. So we got, let's go down a little bit. X squared plus 10x. And I'm going to leave a space. And then I got plus y squared minus 8y. And again, I want a space there because I'm going to be completing the square for both of these. To complete the square, you take the linear term coefficient, you cut it in half, square it, and that's what you're going to add there. So half of 10 is 5, square that is 25, so we're going to add 25. And you can't just do that on one side of the equation, you have to do it on the other side as well, so you add 25. And we're going to complete the square on the y part. Again, you take the linear term, you cut it in half, and you square it, and that's what you'll add up there. Half of -8 is -4 squared is 16, so we're going to add 16. And over here, again, you have to add it on the other side of your equation as well. And now that we've done that, we can rewrite both of these parts as perfect squares. The blue part comes out to be x plus 5 squared. If you were to re-square this, you'd get this, so we're unsquaring it, turning it into the perfect square that it is. And then for the y part, we got y minus 4 squared. And this number comes from half the linear term that's in the middle there. And these are being added together, and it's going to equal our right side, which, hold on, give me a sec, I'll add that up. Alright, it comes out to be 174. So now we have this, we can get our center from these two numbers. Remember, it's supposed to be x minus the number. If you look at your notes there, it's x minus the number squared and y minus the number squared. Those are the center numbers, or coordinates, sorry. And you're looking at negative 5 and then positive 4. So our center is at negative 5, 4. And then in the equation, the right side of it, this is r squared. And we want r being the radius. So you just square root it. So it's the square root of 174. And that does have a decimal approximation, but we don't need it. We just have the exact value there of square root of 174. All right, so let's jump to some of these other sections. It's a lot of reading the equation, getting information that you need, and using that information to get other things. So when I look at this equation, I notice right away that it has a plus in the middle and lets me know that this is an ellipse. And then I can notice which one of these has a bigger number on bottom. The y does, and that'll mean that this is a vertical ellipse, or it's taller than it is wide. So this number is going to be a squared, which will mean a is the square root of that, which is 15. And that'll mean that this number is b squared, which will mean that b is 10. The a part will be useful in getting the vertices, because your vertices are your center and then plus or minus a in the vertical direction, because it's a vertical ellipse. So let's go ahead and get the center based on these top numbers here. It's x minus h and y minus k. So your center is going to be at 8, 8. And now that we have that, we can take the y coordinate and add and subtract 15 to get the vertex. So let me switch colors so you can kind of see it. So our vertices here are going to be 8, and then 8 plus or minus my a value, 15, which spawns 2 points. We got 8, and then 23, and then it's 8, negative 7. So there's our vertices here. And we also have to get our foci. The foci are the center, but then plus or minus the c value on the y component, because it's a vertical ellipse. Well, we need to get our c value. And if you're going to get your c value, you have to use the proper Pythagorean relation. So go back to your notes. Again, ellipses. And you got to look at your Pythagorean relation, which is a squared is b squared plus c squared. You do want to check those because sometimes it's like the normal Pythagorean theorem and sometimes it's not. Mainly ellipses, it's not. So let's go back and use that to get our c value. So remember, it's a squared is b squared plus c squared. We already have our a squared value. It's 225. And we also have our b squared value, which is 100. And so we can subtract off this 100 to get c squared. So c squared is 125. And you can square root that to get your c value. So c is the square root of 125. Not a nice number, but you can deal with it. So that's going to make this 8, and then 8 plus or minus root 125, which if you write it out as your two separate points, you're looking at 8, and then 8 plus square root of 125, and then 8 minus square root of 125. So there you go, we got our foci, we got our vertices for this problem. So I'm going to pause it, stop this video, and then the next one will have additional examples from your assignment.